Hello, math nerds. It's the craziest math nerd of all, Katie Morgan here. And today we're going to go away from infinity for a minute, and we're going to talk about limits of points within the function, not going like to the left or right forever, but to points on a function. And so I have created this crazy function that has all this crazy stuff going on, and we're going to look at some very interesting points and see if we can't see some patterns, okay? So let's read what we need to do for each point, and then we'll go find each point and answer the question. So it says, describe the function graphically. What is the y value approaching as you approach the x value from the left? Okay. What y value are you approaching as the x value comes from the right, as you approach the x value from the right? How about both sides, both directions? And is it continuous? Okay, so we're going to go to, let's look. We're going to go to -2, -1, 0, 1, and 3, and see what we think about that. So let's look at -2, and we'll talk about this, and then we'll answer all of our chart. So here's -2, and here's the point at -2. And at that point, the function is very smooth. There's no asymptotes or holes or jumps or breaks or anything. It's just a nice smooth part. So for the description of the graph, I'm going to say it is smooth there. Okay. Then it asks you about the y value that the function's approaching as you go to -2 from the left. So here is the point -2. If I go to the left, that direction is left, by the way. And for those of you who have a hard time with left and right, if you hold your left hand up, it makes an L. That's how you can remember that, just FYI. So if you go to the left, don't go far, and go towards that value, what y value are you approaching? And it looks like there's actually a point at 2, 4. Looks like there's a point actually at 2, 4. So if it's smooth, then I'm actually approaching 4 because that's the point on it. So I'm going to write that. And if it is smooth, if I come in from the right, that means go to the right a little bit, just a little bit, and go towards, sorry about that, and go towards -2, then I'm also seeing a y value of 4. And both sides are actually approaching the same value, and the function is actually nice and continuous there. So yes, it is continuous. Because, you know, if you can take a pen, and we erase all this, if you can take a pen and trace through the point and not pick up your pen or pencil, you know that it's continuous. You know that old saying that we did like in what, 8th grade or whatever? Yeah. All right, let's look at -1. I'm a little scared about this one. All right, first of all, let's find out where -1 is. It's right there. It's that hole right there. So if I'm going to describe this, I'm going to say there's a hole in the graph. But as you come into this graph from the left and from the right, you are still approaching that value that would be there if it could be there, which looks like 3. So as you come in from the left and come in from the right, it does approach the same thing. So it says what y value is the graph approaching. It doesn't say you have to get there. It just says you have to go towards it. And both sides are approaching 3. But then it asks the question, is it continuous? No. Why is that, you say? Well, you know, if I'm drawing this, I've got to pick up my pen and go to the next side and keep going, right? Because there's a hole there. So there is a limit, that both sides do approach the same value, but it is not continuous there. All right. We're just answering questions like we did yesterday, aren't we? Just crazy. All right. Let's go to 0. So where is 0? There's 0. And go down to the, Lordy mercy, go down to the point that goes with it. And there's the point 0, actually -1. That's also a nice smooth place, right? So I'm going to write the word smooth. And as you come in from the left, you're going to this y value of -1. And as you come in from the right, you go to the y value of -1. So both directions are approaching -1, and it is continuous there. All right, let's see. The next one I have to look at is 1 and then 3. Oh my goodness. That is crazy. What happens here is just nutty, right? And that is a special kind of discontinuity that we learned back in Algebra 2 and Pre-Cal, and that is called jump discontinuity. Because if you were graphing this, let's get on it. You have to jump up here. You have to jump up in order to get it to graph the rest of it. So to describe the graph, you would say this is a jump in the graph. Okay. Now we got to answer the left and right questions. So here is where 1 is on the graph. So to get on the left-hand side, you have to go to the left, and don't go too far. Just go a little bit and go towards that x value. What y value are you approaching? Well, it looks like it's -2 right there. All right, so -2. And then if you go to the right, so here's the point that you're talking about at 1, go to the right on the function, go somewhere and go towards that value. And what y value are you approaching? And that looks like 1. It says from both directions. Well, both directions don't have the same answer. So that's not it. We don't have one. We don't have one. And it is not continuous there because there is a jump in the graph, right? I would definitely have to pick up my pen to go to the next piece of that. 3 is our next value, and so here's where 3 is, like in the graph. So I drew that in. I didn't mean to, but that looks like that's a place where the graph is running up and down that, and that looks like a vertical asymptote to me. So I'm going to write vertical asymptote here. And then I have to go from the left and the right. Okay, sorry, my page just moved on me. If this is 3, then if you go to the left of 3 and you follow, and that looks like that's going up forever. And yesterday we said if we have an answer that is up forever, that's what the y's are doing, then we answer that by positive infinity. Oh, this sounds like what we did yesterday. And then if we go to the right of 3 and we travel, the y's go down forever. And we said yesterday to say that we write down forever is negative infinity. And then they do not match. And it is not continuous because you definitely have a vertical asymptote there, and you know that's a place of discontinuity. So I can answer these questions. I can do this, but now let's put the symbols with the questions. Okay? All right, so how do you say and I'm going to do this. How do you say all of these words in symbols? It's not hard, it's just different, right? So let's talk about this one first. All right. You approach the x value from the left. So if you're trying to find a y value that the graph is approaching, then you're really asking for a limit, like we did yesterday. So I'm going to write limit as x approaches, and instead of using a particular number, I'm going to do this in general, and I'm going to call the x value we're going to a. That's just something we do. And to indicate it's from the left, you're going to do a little minus sign by the a, and that means from the left of f of x equals, and then that's what it equals. To find a y value that you're approaching means I want a limit. So I want the limit as x approaches some number, but how do I say from the right? Well, if the left is minus, I guess the right would be plus, right? Got to be careful when you say all this right and left and stuff. And so if you have a little dash above or a plus above your number, then that means coming from one direction. If you have a limit as x approaches and you just have one, you don't have a symbol, but you just have a number there, then that means from both directions. So both directions does not have anything right there. I'm going to erase that, maybe. Well, I erased it all, didn't I? Lord. All right. So I'm going to show you how you would write. Let's go do one. Let's go do that one. So I'm going to write this up here. So the limit as x approaches 1 from the left, and we said the answer was -2. And the limit as x approaches 1 from the right, we said was 1. And the limit as x approaches 1, that means from both directions, and they didn't go to the same thing, did they? So we say that does not exist. So if there is not a value that you approach, the answer is does not exist, just like yesterday, right? Except we're just going to a number this time, but the same concept applies. And so that's how you would write those three limits. Okay? All right, this isn't terrible. One of the things I need you to remember is, let me write this limit. The limit for 3, the limit as x approaches 3 from the left equals positive infinity. That is how you write that. But how you think about it is, as you go to 3 from the left, to your function, your y values go up forever. So that whole deal we did yesterday still applies to this, and you got to think about it. So if you go up forever on one side, and on the other side, as x approaches 3 from the right, you go down forever, that kind of tells you that at 3, 2, 3, that goes up forever and down forever, that tells you there's probably a vertical asymptote there, and that's how the graph is acting as it gets close to the asymptote. You know how you have to run up or down an asymptote? And so that tells you the direction. And eventually we'll get to that. We'll be able to look at these symbols and talk to you about what the graph looks like. Isn't that great? All right, so now it's time for you to go look at some and work some and have a lot of fun, okay? Have fun. Thanks so much.